So, good afternoon. Thank you, Michaela, again for the nice introduction. Actually, it was interesting how Frederick and myself, we got together to develop this document on software supply chain security. So we met only for the first time at the CNCF in Seattle this February. And that's where we decided to put our heads together, and then I wanted to seek Frederick guidance because he's a practitioner with a lot of, as Michaela said, he wears many hats, and he's quite hands-on in this area. So, but basically we wanted to address from the fact that we have been used to what is called the software development lifecycle SDLC processes for quite some time now, and there are many frameworks and so on. So how is it that software supply chain is different from all of them? So we wanted to first get into understanding the semantics of what is software supply chain, and then go on to how you can utilize the various processes and frameworks that are being under development, and some of them have reached a certain level of maturity as well. So that's, as I said, we will first get into the definition and the problem. So we know in a very generic sense that software supply chain is a set of operations or collection of operations that produce, transform, and evaluate software artifacts. So in other words, it produces some artifacts and it does transform from one artifact to the other or combine artifacts. And then lastly, we want to evaluate how good it meets the requirements. And then in terms of the software supply chain, the modern context of the open source, proprietary and software and so on, it is acted upon by different organizations and different actors, and each of them guided by different policies because they all operate in different domain. So, but the reality is that today there are the attacks against software supply chain has increased, and that's the problem that we want to address today. So what is really in order to get at the semantics better, so we decided to look at what really are the steps that are involved. So basically there are three things that are involved in software supply chain. One is each of the steps involve using some artifacts. Then second is consuming some artifacts, and then third is producing some artifacts. So as you could see here, we are given examples that we use compilers and linkers, and then those are the things that we use. And then we consume artifacts, which is the source code, and then produce a binary, then that's what we produce actually. And then in this process, while doing so, we know that in any of the steps, certain defects could be introduced. So either intentionally or oversight and so on. So based upon the intent, we decided to classify what is known as software supply chain defects and software supply chain attacks. So in defects, we know that anytime a defect is introduced, of course, it gets propagated automatically and then shows up in the end product, and then that decides the security profile of the end product. Whereas what is different in the attacks is it is quite intentional. So specifically that step is being compromised. So what is being compromised? A malicious property compromises either with the steps itself or the artifact that are being used in the steps, or the actors who are involved in the steps, like for example, stealing credentials and so on. So those are the ways in which a malicious party actually tampers with the whole steps with the intention of exploiting it when it becomes a finished product. And that's the difference between a software supply chain defect and software supply chain attack. So that we wanted to make a clear distinction in order to understand the problem better. So with that background, we decided that we will produce a guidance document with respect to software supply chain security. And then here, that in software supply chain, we cannot produce a reference architecture like zero trust architecture, because everybody is guided by different policies and different methodologies are being used for SDLC and so on. So instead, we decided to get at the fundamentals of what are all the desirable security properties that we expect from a software supply chain. And then guidance for actionable security in order to realize those properties. And then also demonstrate the whole methodology in the context of CI/CD pipelines, because we know that DevSecOps is increasingly being used for developing cloud-native software. And then using the process of CI/CD pipelines, we thought that we could use it as a case study demonstration. So then we will have a brief look in view of the time. We may not be able to discuss in detail all the desirable security properties, which we of course intend doing that in our document. But in this presentation, we will take a stratospheric view of what are the desirable properties. So the desirable properties are actually realized through a combination of processes and frameworks. So there are plenty of processes now, and the first is the workload identity processes, which we have seen in terms of the SVP infrastructure and so on. And then we do have, this is a well-known actor identity is nothing but user identity. So we do know all the properties that a user identity has to satisfy and all the infrastructures that are currently available for issuing user identities. And then specifically with respect to software supply chain, we do have specific processes like SBOM generation, and then the signing process and so on. And then the whole concept of the attestation and provenance framework, which incorporates all these processes, the SBOM and the signing processes and so on. In addition to that, there are other processes like dependency management and timestamps and so on. So just a flavor for, see what are all the requirements for SBOM processes, because knowing the requirements is one that can generate desirable security properties. For example, in SBOM generation, it needs to be of a standard format, and then it should provide coverage for all types of software, not just internally developed. And also it should be not manually generated, but automatically generated. And nowadays, the software composition analysis tool have got this feature of generating SBOMs. And then, last but not the least, it should definitely have linkage to vulnerability data, because we need to have not only details about vulnerability data, but also to see whether the current status is there. So whether it has been fixed or still under investigation and so on. And also its exploitability information. So we know that, as we were discussing one day, we are living with so many vulnerabilities in the basic Linux kernel itself, but then under what condition they can be exploited? Only if it is a root access and so on. So in other words, knowing the exploitability condition in the context of the artifacts is really very important. We cannot definitely say that something is vulnerable just because it exists. And then, of course, it should have domain-specific information added to that. So then moving on to our requirements. So we know that one of the important frameworks that is being developed, like in Toto and so on. So they rely upon various types of attestations. So you do have the concept of build attestations, which actually specifies how the build process was performed, whether it was done on a developer workstation or in a central hardened server. So that is very, very important, the build attestation. And secondly, the second is the dependency attestation. So dependency attestation is definitely needed especially when you procure third-party software. It doesn't matter whether it's open source or proprietary. And then this dependency also should tell us whether the dependency was created using the original source code itself, what was combined, or a pre-compiled binary was used. So all those information that is needed in the dependency attestation. So this is an overview of all the requirements that are needed for getting the desirable properties. And then we know that there are frameworks like in Toto that actually provide an assigned layouts of what are all the steps that are going to be involved in SSC for that particular context or the domain that we are talking about. So we need to create an authenticated layouts. Layouts are nothing but the sequence of steps involved. And then we need to be able to verify them also once the sequence of steps are involved. And then you will be able to verify whether each step was carried out by the right person, using the right command, and using the right linkages of files and other artifacts. So that is as far as the desirable properties are concerned. Next, okay, we do have, so these are all good to have properties. Now how to realize those properties in the actual execution of the steps. And that's where Frederick will actually go through and describe what are all the things that could be done to realize those properties.
So in order to get started, part of what I want to tie this into is look at the theme of what's being discussed from a security side. And we want to build on top of some of those themes. So the very first thing is we need to get the basics right. So the basics include things like if you're building your software on a developer workstation and shipping the software that comes directly off of that system, you should probably move to a CI/CD system, something you can harden, something that you can actually enforce your CI/CD processes. And of course, that CI/CD system itself should follow good baselines. You should have good patch management. So before you even start looking at any of the more advanced stuff, you need to work on getting the basics. So let's assume that you have a system that has those basics put in place. So the theme that we've been seeing in terms of zero trust is basically been following the concept of how do you start off with proving that something should have access to something? And so you have to start off with some form of attestation. That attestation says, I have some device that has been provided that has maybe a TPM or has an AWS identity document or GCP workload identity or so on. And that gets, and you then provide some form of identity that you can then reason about. The example you saw before with some of the groups was with Spiffy. Once you know what that system is, then it's authorized to do certain things, and that decision, there's some form of enforcement point that's on there. And that enforcement point, and the way you manage that enforcement point is not done through hands on keyboard or through what they call click ops, somebody clicking on a UI, but instead is done through some form of, also through a CI/CD system, something that is something that gives you that control and auditability. So likewise, in software supply chain, we have a similar set of concepts. It's like, where does this thing come from? How do we cryptographically identify the build system? How do we gather attestations that describe the software development lifecycle? And once you gather that, then you package and you sign your attestations. And those that becomes evidence. And one of the primary differences when we look at zero trust is that you have that evidence and that is used ephemerally. You want to make use of it at that specific moment with some timeline. So on the software side, it's a little bit, on the software supply chain side, it's a little bit different because you make some attestation. That attestation is going to be used by some consumer later on, and it may be months later when they look at the processes, like did this follow the correct set of processes? Did it originate from a well-known developer who I trust, or did it get the right set of code reviews? So you have that evidence, and you would analyze the evidence in order to determine whether you want to run some piece of software or not, and lift it into, and then that becomes additional evidence that then ties into your zero trust platform. So we need to look at it from source, from that origination, and tie it all the way through. How do we attest the various sections of it until we get down to the final part in terms of attesting into a zero trust environment. So it's not like it's disjoint, it's all part of the same fabric, using similar concepts. So that is the basic approach, is think of it as like evidence-based authentication and authorization as the approach, and which is what we're doing in zero trust. It's also what we're doing towards the supply chain. Now, one of the problems, though, is that the evidence we can gather today is not as accurate as we would like. it's noisy, and we're going to get better at collecting and working through this particular evidence. So this is something that is going to evolve over time. And this is important because that means the infrastructure we build today has to be flexible enough to handle the evidence of tomorrow. So so in the future, the evidence will become more rich. It'll become more robust to changes. It'll become more accurate. And as it becomes more accurate, we will be able to perform more granular, more accurate attestations that you can then bind against and make decisions. An important part of this, though, is this will only work if we can get organizations to rally around given a set of open standards. So the standards that you use within your supply chain, like what is your SBOM? It's like we don't want to have a massive proliferation of SBOM formats out there because then the cost of ingesting becomes very expensive. So ideally, we want to encourage people to rally around, and if the standards are lacking, to get involved with those standards in order to provide them that feedback as to what is missing, so that way that you're able to get the evidence that you need. And the same approach also works when you're working with a vendor. If the vendor is not producing enough information for you to make a decision, like maybe you need to have information about, did you do a code scan or did you do a scan of the artifact afterwards? If they've not provided you with enough information, then you should be able to have that conversation with your developers or with your vendors so that they can expose what they're doing there. And then you can make a decision based upon the risk profile of what you're running. So like a risk profile of maybe a small, simple game might be quite low, but if you're running it for very sensitive data, then you can look at what the process is and make a better decision. So in short, part of the approach of what we've been trying to do here is we want to make a nod that the software supply chain itself is very diverse, is very rich, but to try to find a set of patterns that can be applied across the board, and then to have certain areas of consolidation around the standard so that you can have very different set of technologies drive. You might have just one set of like how you do it in Go versus how you do it in Python versus how you do it in Node.js or similar, all very different, but to be able to have a common language that even across these technology stacks you can still reason about what actually happened, what went into them. This is particularly important as well when you consider that many systems are, when you look at systems that are running today, we have some systems that were built in the 80s or 90s or similar. They're not cloud native. They're not running in the type of environments that you would find developers try to work in today. So it's important as well that what we build and what we work on is able to integrate with these systems and not force them necessarily to change, but to be able to work with them and complement what the developers are doing and capture information about the software development lifecycle that they're performing, and augment the processes through a side-by-side step. So ideally, in greenfield environments, you could tie it really close into the actual build and development system, but it needs to be flexible enough to handle systems that are running very critical infrastructure today.
So specifically in that context, we thought that we could give you this how this software supply chain methods, whether there are some targeted strategies for CI/CD pipelines. For these CI/CD pipelines, in order to come up with the targeted strategies for CI/CD pipelines, we need to know that what exactly is being done there. So I'm sorry. So we need to analyze what are the actual operations that we do in CI/CD pipelines in order to secure the supply chains. So specifically, we find that in CI/CD pipelines, we do a bunch of operations of checking in and checking out source code from either SCMs or Git repositories. And then we do the build process and then the storage. And then these storage not only build artifacts, but also the package artifacts, the final things that are being delivered. And then, of course, it is not a do once and keep quiet. So these packages are to be repackaged either because of configuration drift or for patching or just simple update of software. So these are some of the conditions that require repackaging, and this gives us an idea of what are all the actions that are being done. So in this context, what are the desirable properties? Because that is our approach. In terms of the desirable properties, so first we should know what are all the platforms that run the builds. So the platforms that run the builds and generate the provenance data must be certified. And then we should, as Frederick alluded to, the production releases should not come out of a developer workstation, but preferably using a centralized CI/CD system. And those are some of the requirements in the context of CI/CD. And also the build metadata that should be generated during the build process itself, and preferably signed during that time itself, although it is possible to sign later on after the build process is over. And the ideal situation is to produce reproducible builds, but there are some practical difficulties as to when that may not be realistic. So that is exactly in the context of, we would like to highlight how to look at it, software supply chain, in the context of DevSecOps and CI/CD pipelines.
Yeah, and to recap, one, we're talking about attestations. So this is not something that we wrote down, but I figure it's important to discuss here. So when you look at software bill of materials, you're asking what went into my software. This is like the ingredient, like if you're looking at a recipe for food, this is like the ingredients that go in. But it's not enough, because if you have a set of ingredients, you don't know how it's going to be used to come up with the final product. Or if you have the final product, it can be difficult or impossible to cost effectively analyze it and determine what went into it. And it's very important to know what went into it, especially if you have some risk like an allergy or something similar. So in the same way, when you have source code, you don't necessarily know how all that source code is going to be put together. Like the Linux kernel itself has an immense number of files, and a very small percentage of them are actually used within the build. So it's important to have the process. So SBOM gives you the materials. Then you need to have something that tells you what process was followed in order to put those things together. One of the systems that I use that you would have seen mentioned before was in Toto. It's not the only format towards that, but it's one that is being used within the open source community. If you're working within the Salsa environment, Salsa actually aligns better with Toto than it does with SBOMs, because it's looking at the process of how something is generated. You also need a way to get vulnerability information out. So those SBOMs become the key to things like CVEs, because CVEs are dynamic information. So you need to have a way to say, this is my key that I'm using to find things like CVEs. So you want that SBOM to accurately depict what is within your environment so that you can go find those things. There's also another project that was done initially through CISA and OASIS, which is the VEX project. So CVEs tell you if you're vulnerable to something. A VEX attestation tells you whether you're affected by it. So there's scenarios where you may be affected, where you may have a vulnerability, but you don't follow that code path, so you're not actually impacted by it. You still want to patch it, but the question then becomes, do I need to take care of it now, or can I wait until my patch cycle takes care of it? So VEX helps answer those particular questions. And so these are examples of some standards that exist today that are helping to drive that conversation. And if you produce these and conform to this, it doesn't matter which technology stack you're following, you'll be able to gain the benefits of this. And as more people start to produce and consume these, then we'll see an amplification effect that allows us to more quickly react to risk, whether the risk comes from an attack or the risk comes from a defect.
So in other words, the two key pieces of information are the build attestation and the dependency attestations, and all the information that goes with this. So the status of vulnerability and so on, as Frederick explained. So these give you the recipe, and then the practitioners can assess the applicability of these and then use that in that particular environment.
Right.
So, and this is what all the issues that we are going to address in our upcoming document, which we plan to release for public comment the end of next month. So that's our timeline.
Also, I'd like to make one quick shout out. The SPIFFE project that you saw before, there actually is a SPIFFE book that's there. I'm one of the co-authors of it. So if you're interested in identity and how identity fits into this and how identity fits into things like software supply chain as well, that's a good place to learn about specifically workload identity.
It's a free ebook that can be downloaded.
Yeah. It's Creative Commons with attribution, so you can share it with others. With that, do we have time for questions still? Okay. Okay, so the first one is, should dependency attestation be an input to iterations of the DevSecOps cycle, maintenance and enhancements? Absolutely. Our expectation is there has to be a bridge. There has to be a moment where we bridge from what we've attested in the supply chain into something that works on the operational side. So the place that we're saying is, what we're seeing happen is we have things to control what is running within a like a Kubernetes cluster or within an orchestrated environment. And those orchestrators are being augmented to analyze the attestations that are being produced so that you can then make a decision. Does this follow my policy? And is there some action you want to take? Where the action might be to enforce, I'm not going to run this, or audit, I am going to run this, but I'm going to raise a red flag to my operations team so they can go work out why this thing is not compliant.
So in other words, integration into the CI/CD pipelines is a requirement, no compromise on that.
Next question was about VEX, where they have minimum requirements for VEX documents and how will it fit within a CI/CD pipeline and how it'll be audited. So that's a good question. VEX is usually something that, there's a couple of things you could do. First, you could collect VEX documents of things that you use, but it's really meant to be a conversation between either a developer or some security analyst who found an issue, and to be able to describe whether a particular group is impacted or not, and to give information about whether it's been mitigated. So right now, the actual sharing of information in keying is very machine readable, but the actual action on how you mitigate something is primarily meant for humans. So you still need a human in the loop at that point to read the document and to make a decision as to whether or not their environment fits. It needs to have some action or not. What I think is going to end up happening if VEX ends up succeeding is that when you do a build and a compile, you can gather what VEX documents are currently there, and you could publish a report on it, but it's important to also remember that VEX documents can be issued after the build, and it's important to not tie yourself. So think of like what you put in what the build produces is going to be static information about the state of the environment, the state of the world. And VEX it falls in a more dynamic environment where you're going to have VEX statements created after the fact, and you need to be able to find those using SBOM as a key into those VEX documents.
Since VEX gives a picture of the current status of the vulnerability.
Right.
So it's the dynamic part, actually.
Correct. So, well, thank you.
Thank you.